So hello students, in previous video we discussed about the all the enthalpies. In today's videos we will discuss about the entropy and another law, which is the law of thermodynamics second, third, and Gibbs free energy. So here are the 3-4 topics we will discuss about today's video. So first we will discuss about the entropy. Entropy, what do you mean by entropy? Entropy means by degree of randomness. Degree of randomness of particle of a system will do random motion. Entropy basically, in like take an example of ice. If we melt ice, then its molecule will do motion, kind of motion, so that motion is known as the entropy. And if we melt ice, the next state will be from the liquid state, so it will be more entropy. In that, entropy level will increase. Okay, so entropy is denoted by S. Okay, or you can say change in entropy which is known as delta S. Okay, also delta S is equal to heat by temperature. Here it is the formula of this. So what will be the SI unit of entropy? Joule by Kelvin. So let's say SI unit will be Joule by Kelvin, or you can say Joule K minus 1. General unit will be kg, kilojoule by Kelvin. Okay, let's take few question on this. If we melt ice, then its molecular speed will increase, so that will be the entropy, so its entropy level will increase. Entropy increase. Take another example. If gas or air is moving, then its particular area will be small and entropy level will increase. Okay, boiling of water. If we boil the water, then its molecular level will increase, so its entropy also increase. And another example will be on water. So formation of H2O liquid using the H2 gas and O2 gas, so its entropy level will decrease because gas has the more entropy level than liquid, so we are converting the gas into liquid, so the process will be reversed and entropy level will decrease. Okay, solid has least entropy level and the gas has more maximum entropy level. Like you can say solid smaller than liquid in the basis of entropy, and gas has the more entropy level. Okay, hope you understand. So now we will discuss about the spontaneous and non-spontaneous method process before the Gibbs free energy. So what do you mean by spontaneous? Spontaneous means automatically to do anything, automatically to do any process, like not any external force is applied, we are not doing anything, it's do by automatically through the nature. Okay, like the evaporation through the sun of the river, it is the spontaneous process. Okay, and non-spontaneous is vice versa of the spontaneous process, it is non-automatic. It is the these are the essential points for the Gibbs free energy topic, so we are discussing before that. It is automatically to do anything, and it is non-automatic, we have to apply any force, or you can say we have to do the work for the non-spontaneous thing, and it is the spontaneous do anything by automatically through the nature power. Gibbs free energy. Gibbs free energy is nothing, energy of a system which can be converted in the form of useful work is called the free Gibbs energy, or you can say Gibbs free energy. Okay, also delta G is equal to delta H minus delta H dash. So delta G will be delta H minus delta HS dash. So we know the entropy formula, delta S is equal to delta H S, because it is the entropy is heat and here is the temperature. So we need the delta HS, so we will do the delta HS. So here will be T into delta S. We put the equation delta G is equal to delta H minus T delta S. Here is the Gibbs energy formula, and here is another Gibbs energy formula, which is delta G is equal to minus 2303 RT log Kc. Kc is for the equilibrium. Equilibrium. Okay. Now we will talk about the if delta G, which is Gibbs energy, if its answer will be negative, then the process will be spontaneous. Spontaneous means automatically to do anything process without any external force, or you can say without any work, by doing its natural process. Process is spontaneous and the Gibbs free energy result is positive, then it is the non-spontaneous process. Non-spontaneous process. Okay. Now we will discuss about the second law of thermodynamics. Second law of thermodynamics said that it indicates the limit of converted heat into work and introduce the principle increase in entropy in a spontaneous process. It is only do in a spontaneous process. It states that the entropy will continuously increase in the universe. So let's say the entropy of the universe is increasing continuously as a result of spontaneous process, process. Okay, now we will do some points. All spontaneous process are irreversible. We cannot do it twice, thrice. Without the help of an external agency, a spontaneous process cannot be reversed. Without any help of the external energy, we cannot do any spontaneous process twice or thrice. Okay, it is always irreversible process without the any external energy, or you can say work. Now we will discuss about the third law of thermodynamics. Third law of thermodynamics states that the entropy of any pure crystal substance approaches zero as the temperature approaches absolute zero. It means the entropy is directly proportional to temperature. Okay, this is called the third law of thermodynamics. Let's say the points: temperature of the system is high, then the entropy will increase, and the temperature of system low, then the entropy of decrease. Okay, temperature of system is high, then entropy will increase, and temperature of system is low, then entropy will decrease. And the second law states that the always do the spontaneous process and it increases always the entropy. Okay, and spontaneous process is irreversible. So you will get the PDF of this chapter in the description. Hopefully you like this, and you have to do like, share and subscribe.